is to emphasize the roots of the characteristic equation of a corresponding to a differential or difference equation. It's important to understand that the roots of the characteristic equation could be the number of roots we have for a degree 2 equation, which is the ones we handle, could be two different roots, one double root, or no root at all. Though we don't find this last case in our problems. What cannot happen is one single root. That cannot happen. Either you have two, one double, or none. For example, these three equations we have here in green. The first one, we try to solve it by the formula. So r equals minus b plus minus square root of b squared minus 4ac divided by 2a. So that's minus 2 plus minus root of minus 36. As we're working with numbers where the negative numbers don't have a square root, this has no roots. Because little bit ugly these roots here, let me rewrite it. So no roots, because this number here is negative and we don't have a square root of negative numbers. The second one, we put r equals to minus b plus minus a square root of b squared minus 4ac divided by 2a. So that's minus 3 plus minus root of 49, which is 7 divided by 2. So we have minus 3 plus 7 over 2, which is 4 over 2, and minus 3 minus 7 over 2, minus 10 over 2, which is minus 5. So we have two different roots. The last case, which I'll make a little bit down here, we have r is equals to minus b plus minus a square root of b squared minus 4ac divided by 2a. So let me write this in a slightly different way so you understand. This is 12 plus minus 0 divided by 2. So we have 12 plus 0 divided by 2, which is 6, and 12 minus 0 divided by 2, which is also 6. So we have one double root, r equals to 6. So we have the three cases, two different roots here, one double root here, and no solution here. A little bit more careful in the case of a double root. There are two possibilities here I'm studying, the differential equation and the differential equation. Starting with the differential equation, suppose we have this y double prime minus 12y prime plus 36 equals to 0. The characteristic equation associated to this is r squared minus 12r plus 36 equals to 0, which, if you remember, is this equation here. Hence, we have a double root, r equals to 6 double root. So we need two different solutions. We cannot write simply y1 equals to e to the 6t, because that's only one solution. We need another solution which cannot be e to the 6t, because in this case they're equal. So therefore we need to put some extra factor, and what we put t. This comes from the double root. And the 6, because this is 6 is the double root. Let me erase here in case it's not understood. This is a 6, not an r. So for difference equation is similar. Here we have a equation of degree 2. The highest subindex is t plus 2. The smallest is t. So in this case, the degree of this equation is equals to t plus 2 minus t, which is equals to 2, and the associated characteristic is r squared minus 12r plus 36 equals to 0. Obviously, I have chosen the same equation to do less work. So here we have a double root given by r equals to 6. So we again need two different solutions. We cannot have one single solution. Repeat it because that's only one. We need two solutions. So we have yt1 equals to 6 to the t, and yt2, this is not a square, this is an index 2. That's also 6 to the t. But then these two, if I leave this like that, both will be equal, so we have to put a t that comes as before from the double root.